All right, up on the board here, we're going to do a short review note session over diatomic and polyatomic, diatomic molecules and polyatomic ions. So go ahead and take your notes out, excuse me, from those specific, from this video. Now, it's pretty basic, okay? Pretty basic, some learning targets for this particular video. I only had 2 of them, so let's check those learning targets out. I can identify the diatomic elements. And what you're going to see is I refer to the diatomic elements as the super 7, and you should have already seen that watching the video. The second learning target is that I can describe a polyatomic ion. Now, the diatomic elements, what I call the super 7, okay? Who can tell me from the video why I call them the super 7? Bree? They are 7 of them. And on the periodic table, they make a 7. So, if I'm looking, starting with element number 7 starting with element number 7 right here. That's another part of the super 7. Starts with element number 7. They make a 7 on the periodic table, other than this guy all the way over here, other than hydrogen. So there are 7 of them. They make a 7 on the periodic table. Thank you. They make a 7 on the periodic table. And they start with element number 7. So, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Ladies and gentlemen, you're super 7. Now, just to show you about these super 7, they are what we call diatomic molecules. So what type of bonding are we dealing with here, folks, if it is a molecule? Molecules are what? They are covalently bonded. So when I'm looking at this, I will not find nitrogen as a single atom. I will find nitrogen as a diatomic atom. So if you stop and think about the air we are breathing right now, correct? The air we are breathing right now has a certain amount of nitrogen in it, doesn't it? Any idea how much? Not higher. The majority of the air we're breathing is nitrogen, about 78%. Okay, so about 78% is diatomic nitrogen. The other, well, not the other, 21% is oxygen. Is oxygen a super 7? Yeah. So diatomic oxygen there is making up another 21%. So that's about 99%. Then you have other trace amounts of gases. But when we have nitrogen, it's going to be diatomic. There's going to be 2 of those around. Now, as a comparison, here are just a collection of argon atoms. Okay? Those are just 1, so they're bouncing around as atoms. Molecules. Atoms. Do you know the difference? Hopefully, yes, you do. If I see an atom, it is a single element. If I see molecule, a molecule of nitrogen here tells me that there are 2 of them bonded together covalently. Molecules, covalent bonding, nitrogen. Here's oxygen gas molecules. Once again, molecules. Molecules tell me that that is covalently bonded. Okay? So oxygen gas molecules tell me that there's two oxygens bonded together. Now here are the super 7. Okay? Here are the super 7. Hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, chlorine. Those are the super 7. I just have here the different atomic radii. Okay, the different atomic radii. And it's expected as we go, when we talked about atomic radii, as we go this way across the periodic table, they generally shrink. As we go down the group, they tend to get bigger. They tend to get bigger. All right? Just another view of that 7 right there. Okay? That 7. Now, here is just, I put this slide on there just so we could have a little bit of an idea of what we're dealing with. And as we can see, based on our colors up there, if something on our periodic table is red, what does that tell us? It's a gas. What is something that is blue? A liquid. Something that is black is a solid. So I can see that bromine is blue, and iodine is black. So bromine down here is a reddish brown liquid. Iodine at 25 degrees Celsius, which is right around room temperature, okay, maybe a little higher, but at 25 degrees Celsius, iodine is a dark purple solid. The rest of these are gases, okay? Colorless hydrogen and nitrogen, okay? Oxygen's a very pale blue, real pale, because you're not going to be able to tell it, all right? Now, let's talk about a polyatomic ion. What is poly? Many. So this literally is an ion that has many atoms. So by definition, looking at that, a polyatomic ion is known as a molecular ion. A molecular ion. What does that mean, you think? What does molecular mean in terms of how we know it? What's it telling us? It's covalent, okay? So a molecular ion is telling us that this is an ion, so it has a charge. It has gained or lost electrons, and it is molecular, so it is covalently bonded. That's a key part you're going to see with this at times on WebAssign, because this type of an ion is covalently bonded, but then it gains or loses electron. So it has both ionic and covalent bonding occurring. Okay? So, as I look, okay, at my covalent bonding, here is the element here is the polyatomic ion NO3 1-. Now, that is what we call the nitrate ion. And you'll learn these polyatomics here in a little bit after we go over nuclear chemistry, which is our next unit that we're going to start today. Okay? Once we go over nuclear chemistry, then we are going to start naming elements. And when we get into the naming elements, you'll run into these polyatomics more. Now, look at what I got what do I got going on here? Okay? As I can see, nitrogen is my central atom. Okay? Oxygen's right here. Notice how this nitrogen, both of those dots are black. So that nitrogen right there is allowing, that nitrogen right there, let me get that off of there, here is allowing this oxygen to use both of those, both of the black electrons. That is what we call a coordinate covalent bond. You don't need to know that, but that's what it is. A coordinate covalent bond is where nitrogen just says, you know, I'm a nice enough element here that I'm going to let you use 2 of my electrons, and I'm not going to get anything in return. Okay? So this oxygen fills its octet by nitrogen allowing it to use those 2. Right here, what is this? 4 electrons being shared. What's 4 electrons being shared? A double bond. Right here, notice that red electron right there. That is the 1. That red electron right there is the 1 electron that is being gained. Okay? So, this whole unit here is covalently bonded together, but yet it has a charge because it gained 1 electron. What you're going to see here a little bit later on is that 1 electron is going to, just like we were talking before with ionic bonding. Who do you think's probably a good element to give 1 electron? Well, these alkali metals right here. So could, for instance, sodium bond with this nitrate right here? Absolutely. Absolutely. Because sodium wants to give up 1 electron. Right here we need 1 electron. So the key point about these polyatomic ions is that they are covalently bonded together, but the whole group has a -1 charge. So they are ions. All right? Note that the 1 extra electron, the red one in this diagram, is required to complete the octets around both oxygen and nitrogen. Now, right here's what I was talking about here. Sodium, right? Sodium has 11 electrons, 1 on its valence level. Wouldn't sodium just love to give its electron right there so that it could have a full shell? Yes, and then we would have the ionic bond, and that would be sodium nitrate right there. Now, with this particular one, I don't know how my slide got screwed up. That should be up here. Okay, I don't know how that got screwed up. I'll have to fix that. But we could have positive. Okay, we could have positive. If it's a positive polyatomic, what does that tell you? Okay, it lost an electron, right? It lost an electron. So if you would look here, okay, these X's are the hydrogens. We know nitrogen has 5. Do you notice that hydrogen right there, that hydrogen right there does not have an X, does it? So actually, all that this hydrogen is just 1 proton coming in there. All right? So that hydrogen did not have an electron associated with it. So we get this positive charge. Typically, ladies and gentlemen, we're only going to see 2 positive charge. This is the ammonium ion, NH4 plus 1. And we also see the hydronium ion, which is H3O plus 1. Okay, so we typically only see a couple polyatomic cations. There's many, many. I'll give you a whole page of polyatomic anions, but typically the cations, we only see a couple of these. Okay,